Welcome all. I'm Greg from GregsTutoringNYC. You can reach me at the email at the bottom, GregsTutoringNYC@gmail.com. So what we're covering right now is grade 6 hard math problems. I'm defining hard math problems through the context of that I've analyzed past New York State exams at that grade level, grade 6, and I've looked at to see what problems the students were getting wrong the most, and that's what this has yielded. I have a whole other aspect of this. We're covering show you work right now. I have a whole other aspect which is multiple choice. If you go to the link GregsTutoringNYC.com hardest math, you can see multiple choice for grade 3, 4, 5, 6, 7, 8. We've already done show you work for grade 3, 4, and 5. So now we're at 6. These are problems given to hundreds of thousands of kids, and they're the ones that keep showing up often as kids getting errors in. So that means hundreds of thousands of kids made an error on some of these problems. It turns out that in the show you work section, that almost universally, almost every question had this problem. So what we basically need to do is go through the questions that New York State released for this section and just basically do them all. Because again, the majority are getting them wrong, and the few that's not the case, it's not going to be that too much of a burden to cover it, because it's not like there was any question where 90% of the kids got them correct. There's nothing near that. I think the closest it gets to is like 70% got it correct or something. So this is not a pretty picture depending on how you look at it. Okay. With that in mind, I am not doing test prep. That's not the purpose of this. This is about trying to figure out what is the concept they're trying to ask you. What are the mathematical techniques you need to use? What should your numeracy be? Your numerical fluidity, right? Things like that, and how you know how to be problem solve, your analytics, and looking at it, say a word question and detecting on what to go on, things like that. Also, alternate ways to solve problems that might be more efficient, might be faster, might just be a way to double check, so that we're trying to open up the mathematical universe, if you will, right? All right, so with that in mind, I'm going to jump into here. Again, if you guys need to contact me with any questions or you need tutoring, hit me up at GregsTutoringNYC@gmail.com. And with all that as the feed into this, let's jump into the first question. This is going to run about an hour. If you prefer, you can pause at every question, try to solve it yourself, and see if number one, if my solution matches your solution, but not only that, to see some extra stuff I do. Sometimes we take a whole bunch of sidebar conversations and then come back to the original question. So I'm throwing out tips and techniques and other stuff as well on top of that. Let me see if my pen tab is working. There we go. A leaky faucet is losing water and is filling a 5-gallon bucket every 20 hours. Okay, at that rate, rate. So maybe this is a rate question. How many gallons of water will the faucet leak in 48 hours? So rate's cool, because normally we can set up a rate as a ratio. So we have 5 gallons to 20 hours. And another way to write that is as a fraction. 5 gallons is to 20 hours. That's our rate. So what is that? That's the rate of the leak. Okay, so I just put our leak equals that. Okay. How many gallons? So we're also need to consider how many gallons, X gallons, in 48 hours. Okay, so we have a ratio here, a ratio here. So the couple ways to do this. One way is to just set this up as a proportion. You set up a proportion by making two ratios equal, because if the leak is at a constant rate, and it is, that's what they're telling us. It's 5 gallons for every 20 hours. They're not telling us it changes, so it's consistent. So what we can do is just assign those to being equivalent to each other, and then do the cross product. My voice is giving out, sorry people. So the cross product is going to tell us first, we're going to do this multiplication. 5 times 48, okay, equals and then we're going to go the other way. I'll check and change the color of this. Equals 20x. Okay? So what we need to do is multiply 48 times 5. You're best off not doing this in your head. It's easy enough to do in your head, but if this is actually for a test, I would advise writing it out. Okay? 5 times 8 is 40. 0, count my 4. 5 times 4 is 20. Plus the 4 is 240. So I get 240 equals 20x. This is our algebra at this point. We're going to divide both sides by 20. Okay, that 20 cancels. These two zeros cancel. And 2 goes into 24 12 times. So we get 12 equals x, or x equals 12. Okay? So let's plug that in. Let's give that a whirl. If 5 was to 20, does it make sense that 12 is to 24? 48? Right? Well, first of all, let's see if the cross product works. We already know this was 240. Is 20 times 12 240? Yes, it is. So if we do the cross product, this was 240, and this was 240. So it's equal. So we know we got the right answer. So let's try this with a different approach. If we had the 5 over the 20, which was our original thing right here, okay, if we simplify that to 1 over 4, it's the same rate. That means 1 gallon for every 4 hours. Doesn't that make sense? So if we multiply this by 5, then this also gets multiplied by 5. And we get back the original fraction there. So it means our simplified rate is actually 1 over 4. We're trying to look for watt over 48. Well, the denominator is 4 times the numerator. So that means if we go in reverse, this needs to be 4 times less. So 48 divided by 4 is 12. All right, so we have a second way to confirm that that's the answer. In fact, we could have actually grokked that from the original. We can see here that 5 times 4 is 20. So we need to do that same reverse thing. We could also look at it backwards and say 20 divided by 4 is 5. Right? So if we come here and we say, right, we're dividing by 4. 48 divided by 4 must be 12. Okay, so we could do this logically if we wanted to, or we can use the cross product. All right, so this question is, the concept is about rates. It's about setting up a ratio. It's about, if you use that technique, setting up a proportion, right? It's also about knowing how to use the cross product technique. We had some multiplication going on here. So the multiplication table, you can never escape. At this point, you guys need to know at least 10 by 10. You should be starting to work on 12 by 12. And if you can pull it off, try to do up to 20 by 20. These are numbers that come up all the time, and it sticks kids in the side every time they need to do a multiplication. For instance, I just did this 8 times 5 and got 40, 0, carry the 4. That you should just be doing that in seconds, microseconds. Okay, that should not be something that's holding you up. Where you go to the side and do 8 plus 8 plus 8 plus 8 plus 8, that's slowing you down. And again, you're going to make an error. You get 16, then you add 8. You're supposed to get 24, and let's say you make it 23. That means whatever answer you get, you would end up getting 39 if you made that error right there. It's worth memorizing these. I know it's not pretty. It's a pain in the neck to do so, but this deals with the fluidity I was mentioning earlier. So again, this is about rate. It's about just mapping the word problem into the ratio. So when we have words like every, we often know there's a ratio. 5 gallons for every 20, right? And that original colon here meant the same thing. 5 is to 20. We could also use per here, right? We often say like you're going 50 miles per hour. Okay, that's the same kind of a thing. 50 miles per hour. And we often even write it with the divide sign there. And this also, we could use the word every. 50 miles every hour. Okay? The opposite is also true. Every hour, you're going 50 miles. So in some cases, we can write that upside down. 1 hour per every 50 miles. So depending on the problem, that's what we do. But they laid this out. We knew the 5 was the numerator because it said 5 for every 20. All right, in a grade 6, they're normally not going to try to mess you guys up by making a tricky word problem or something at that level, unless you're doing something more complicated. So again, this is rates, setting it up in ratios, and using a proportion seems the most straightforward way. The second way I did mostly in the green on the right-hand side was basically using logic to know that 5 over 20 was the same as 1 over 4. All right, so that's that one. And again, we can use our clues here. We know the answer needs to be in gallons. Okay, and if we go back, it probably said that. How many gallons right up here? So the answer we get needs to make sense, right? And we can even estimate if it was 5 is to 20, right? Equals how many over 48, okay? You can't get an answer here like 1,000, right? If you just make sense that, but that there's a magnitude here, we can do that. We can also do, this was about 50, right? This is about 50. So this is about 2.5 times. So what's about 2.5 times 5, right? It's about 10 or 15 or whatever. So that's where the 12 comes in, right? That's how the 12 comes into place. So you can make sense of some of this even if you don't have the right answer, right? For argument's sake, if it was 5 over 20 and instead of 48, it said 40, it should just leap out at you. Obviously, the answer is 10 in that case, right? It's just twice the amount, then it's twice the numerator as well. All right? What did I do here? Okay, 57 is pretty ugly. It's PEMDAS on steroids. And it's also involving mixed fractions and stuff like that. So let's go for it. We have to do the parentheses first. So we get 8 1/5 minus 2, right? So that's a pretty easy one because we're just subtracting the 2. We get 6 1/5 there. All right? Okay, 4 to the cubed means 4 times 4 times 4. 4 times 4 is 16 times 4 gives 64. By the way, a cute way to multiply by 4, we could have gone on the side and did 16 times 4. 6 times 4 is 24. Carry on my 2. 4 times 1 is 4 plus 2 is 6. But when we multiply 4, we can take a number and double it. So we had 4 times 4 is 16. 4 is the same as 2 times 2. Okay? So if we double that, we get 32. And if we double it one more time, we get to 64. So sometimes you can do multiply by 4 really quick. Let's say it was 17 times 4. Double it, right? We get 34. Double that, we get 68. So sometimes you can do that faster than doing 17 times 4 like that. 7 times 4 is 28. Carry the 2. 4 times 1 is 4 plus 2 is 68, right? It's almost equal, but in any event, it's a way to double check it. So we get 64. So what we have is 24 3/5 plus 64 times, right? There's a multiplication right there. And that's what makes this problem second nasty, times 6 1/5. Okay, so before I proceed further, I'm going to double check. I have a slight dyslexia, so I want to make sure I have the numbers right. 8 1/5 minus 2 is 6 1/5. 4 the cube is 6 1/5, and right, I do. So this is our new equation that we need to figure out. So we can convert the right-hand side into fifths. So this is the same as 31 fifths, right? So we have 64 times 31 fifths. So we can do 64 times 31. 6, 4, 4 times 3 is 12, 1, 18, 19. 8, 1984. I'm going to do that backwards to make sure that I did that correct. 4 times 1 is 4. 4 times 3 is 12. 6 times 1 is 6. 6 times 3 is 18. Okay, 4, 8, 9. So we get 1984 over 5. Okay, we can convert this into fifths. So we have 24 times 5 is 120, plus the 3 is 123 over 5. Okay, and we can double check that. 24 times 5. 5 times 4 is 20, 0, count by 2. 5 times 2 is 10, 11, 12. So we get 120, and then we add that 3 into there. So now what we have to do is 1984 plus 123. 4 plus 3 is 7. 8 plus 2 is 10, 0, count by 1. 9, 10, 11, 1, count by 1. So we should get 2107 over 5. Okay? It just says find the value, so technically that can be our answer if you wanted it to. Let's actually do the division. $2107 divided by 5. 5 goes into 2, can't go. 5 goes into 21 4 times with 1 left over. 5 goes into 10 twice. 5 goes into 7 once with the remainder of 2. So this is 421 and 2/5 if I did that right. Okay, so that's a pretty long-winded answer there. And let's just double check here. It just says the answer. There's no units here. It's just raw numbers that we were mucking about with here. There's other ways to have done this problem. We could have left it in fifths. We could have used other techniques to do the 64 times the 6 1/5. Okay. Just an example. Let me change the color of this for 1 second. So we could have taken this 1984 divided by 5. 5 goes into 19 3 times, that's 15, with 4 left over. 5 goes into 48 9 times, that's 45, with 3 left over, right? 5 goes into 34 6 times, with 4 left over. Okay, so do you see why that's the multiplication table is important, that we could just kind of just zoom through some of these kind of things, right? So what we want to do is, since the 194 over 5 was this part here, we want to add 396 and 4/5 with the 24 and 3/5. So there we get 3/5 plus 4/5 is 7/5. 6 plus 4 is 0, 1. 9, 10, 2, 1, 4. So we get 420 and 7/5. 7/5 is the same as 1 and 2/5. So we have 420 plus 1 and 2/5 gives us 421 and 2/5. And that's the same as the answer we got before. Oh yeah. Oh yeah, right? And just for exposition purposes, let's change this to purple. We could have taken this 64 and 1/5 and used the distributive property on it. So let's bring that to where? 64 times 6 and 1/5. Well, 6 and 1/5 is the same as 6 plus 1/5. So this becomes 64 times that. So this is our, right, we know A times B plus C, whoops, I put 2 pluses there, is equal to A times B plus A times C. So let's do that. 64 is our A, right? If I put A there, B there, and C there. So you have A times B, we have 64 times 6 plus 64 over 5. Okay? So 64 times 6, let's do that. We get 6 times 4 is 24. Carry out 2. 6 times 6 is 36. 37, 38. So we get 384. Plus, and now if we do 64 divided by 5, 5 goes into 6 once with 1 left over. 5 goes into here twice with 4/5 left over. Okay, did I do that right? 60, yep. So what we're going to add to this is 12 and 4/5. So if we add 344 plus 12 and 4/5, we get no 4/5 here, plus 4/5, we get 4/5. 4 plus 2 is 6. 3 plus 1 is 5, and that's 3. We get 356, okay, and 4/5. Okay, there's a slight mistake. Right here, I got 384. Again, this is my dyslexia at work. And over here, I wrote 344. This is 384. So 384, that would make that a 9. This turns out to be the same answer we got over here, the 396 plus 45. So that's another way to have solved it. So if you come back to the problem, this is PEMDAS. It's fractions, it's mixed numbers, it's converting between fractions and mixed numbers, a whole bunch of stuff. And by the way, since the answer was 421 and 2/5, we could also convert a 2/5 to 4/10 and gotten 421.4 as our answer as well. On that note, we can convert everything to that. So let's take another sidebar real quick. Change the color just one more time. Let's use this fuchsia. I think that's what that's called. The 24.35 would have been 24.6, right? Because 3/5 is 6/10, plus the 64 times, and 8 and 1/5 is the same as, well, 1/5 is 2/10, 8.2 minus 2, right? So we could have computed this with decimals through the whole thing, right? So 8.2 minus 2, this becomes 6.2. Okay, times 4, that was 64. So we would have to do 64 times 6.2 and then add 24.6. So why don't we do that real quick? 64 times 6.2. And I've been lucky so far. I haven't made any errors, except for that dyslexia error with the 384 or whatever, but I haven't done any multiplication errors yet. So let's just see here. 4 times 2 is 8. 6 times 2 is 12. 6 times 4 is 24. Carry the 2. 6 times 6 is 36, plus 2 is 38. Okay. So we get 8, 6, 9, 3968. Was that any number I got in the middle of here anywhere? Yeah, it is. It's right here. That's the 396 right here. 396 and 4/5. 4/5 is the same as 8/10. So I have one decimal point here. I move the decimal point over there, and I get 396.8. That's the same number there. All right? So, and then all we have to do is, so once we have that, when we have the 396.8, just come back and add the 24.6 to it. 8 plus 6 is 14, 4. Carry the 1. 6 plus 4 is 10, plus 1 is 11, 1. 9, 10, 11, 12, 1. So that's 421. And we have one decimal place here and one decimal place there. So we end up getting The 421 again, 0.4, right? We said that over here, 421.4. All right, so we're cool, yeah. Works out nice. Okay. So that's about PEMDAS. It's about order of operations. It's about exponents. It's about mixed fractions. This is the whole spiel just thrown at us. It's busy. I showed you 3 different ways to solve this, just to be clear. There's the original green way, there's the red way, and there's this pinkish fuchsia way that you could approach it. It's ways to double check. Probably the initial way may have been the simplest way, but not necessarily. You just never know. All right, so that was 57. Okay, 58 throws an illustration at us. So I like to look at illustrations. We have, what do we have? We have an x-axis, cool. We have a y-axis, cool. It's in units of 2, 2, 4, 6, 8, 10. Going backwards is the same way. The y-axis is the same, 2, 4, 6, 8, 10. Negative also. So each little cube here is a 2 by 2, not a 1 by 1. That throws off some students sometimes when they're doing their things. And we notice the answer already is in units. Okay? So it says the endpoints of a line segment can be represented on a coordinate geometry by the points A being 4 minus 1. So it's normally x comma y is how our things go. So the way to memorize it is we going to move a ladder back and forth. That's along the x-axis, and then go up and down the ladder to get a book in a library, let's see. Okay, so we're going to go to minus 4, 1. It's going to be right there for A. Okay, that's A. Okay, it says graph and label each of the endpoints. So this is A, okay, that's minus 4, 1. C is minus 4, minus 3. So that's going to be right here. That's where C is then, right? So we graphed it, we labeled it, okay? Okay, let's reread it. The endpoints of a line segment. So there's a line segment basically from here to here. Okay, so a line segment has distinct endpoints. Normally when we draw a line, it's like that with the arrows, okay? So when there's a line segment, it has distinct ending points to it. And we normally put these little dots on them. That's why when we talk about the number line, we use the little dots, okay? So the endpoints of a line segment can be represented on a coordinate grid by the points minus 4, 1. Okay, we went over to the left 4 and up 1. Okay, for C, we went over minus 4 and we went down 3. So graph and label, we graphed, we labeled, because I put A and C, each of the endpoints of the line segment on the coordinate grid below. So we answered this part of it. Then it says, what is the distance in units between A and C? So really what we need to do is count the number of boxes. Let me change the color slightly for that. So from here to here is 1, right? Because each cube was 2. Okay, there's a whole cube here now. So that's 2. And then there's half of a cube again. So that's 1. So what we have is 1 plus 2 plus 1. And that's equal to 4. Okay, so we can get that answer visually. We could have also done a subtraction because what we're doing is we're working on the y parts now, right? It's x comma y. So what we need to do is compare this 3 to this minus 1. So we can subtract, right? 1 minus the other one, minus 3. So 1 minus minus becomes plus. So we get 1 plus 3 is equal to 4. Notice we get the same answer again now. Okay, we could have done this in reverse as well, and we could have done minus 3 minus the other one, minus 1. That gives us minus 4. So wait, what's going on here? Well, you have to realize that distance is normally considered as the absolute value of it. There's different contexts of this, so you have to be careful. But if we're talking about the distance, they're asking basically, what is the length of the line segment, right? We can't say the line segment is minus 4 inches or something like that. So we have to take the absolute value of it and still get a 4 for that as well, right? So this is about geometry. In fact, it's about coordinate geometry because it's not particularly about shapes. It's about scaling. We know normally there's a key on the side that might say this is a 2 and this is 2 or something, but it didn't give us this, and we figured that out because this is 2, 4, 6, 8, 10. All right? So we don't always need the key, and you always have to look to see how far apart is each thing. In fact, you also have to see if the center here is actually 0, 0. Some of the XYs, there might be like a little, looks like a little lightning bolt on it, and it might start at like 20. It means the other part here, or even on the y-axis, and it can go this way and this way as well, it means it's not important for the problem at hand. But it's easy to miss that little lightning bolt sometimes and think it starts at 0, but it may not. Okay? An example is if you're graphing like transactions from a bank might only be producing numbers in the millions of dollars. So it might skip over and start at 1 million. Okay? Actually, the number 1 million. It could also scale it and say every number is equal to 1 million. In that case, it would be a key or a caption or a legend or something on the side saying that. So there's a whole bunch of different ways to do this. So this is pretty much about knowing what the coordinate geometry means. Okay, what x comma y is about, and just counting. All right. So luckily, this was small enough here that we could actually count the units. But you should really know this technique over here as well, where you're actually subtracting the two. Of course, minus 4 minus a minus 4 is not the right thing because that's using x's first of all. Second of all, it would have produced 0 because minus 4 and minus 4 means minus 4 plus 4 because a minus minus is a plus, and that's equal to 0. And if you guys don't know your positive negative rules for addition and your positive negative rules for multiplication, it's a good time to review them, right? So that's 59, 60 is a word problem. It looks a little busy. There's a few numbers. I see Celsius and Fahrenheit leaping out at me without reading it yet. To convert a temperature from degrees Celsius to Fahrenheit, so we're going from Celsius to Fahrenheit, the temperature degrees Celsius is multiplied by 1.8. So let's take that in a few steps at a time. We're up to here. To convert a temperature from Celsius to Fahrenheit, the temperature is multiplied, Celsius is multiplied by 1.8. So you have 1.8 times C. And then 32 is added to that product. So plus 32. Okay? So to convert it from Celsius to Fahrenheit, that's a formula. So think that through. Run through the words again. To convert a temperature from degrees Celsius, right here, we have the Celsius. We're going to multiply it by 1.8, okay, and then add 32. All right, and that's our new Fahrenheit. So it says write an expression that can be used to convert a temperature from degrees Celsius to degrees Fahrenheit. So there you go. I already did that. And then use that expression to convert 25 degrees to Fahrenheit. So what we have is basically 1.8 times 25, because that was the Celsius they gave us, right? Plus 32. So we can go on the side and do our 18, or 1.8 times 25. 5 times 4 is 40, 0, 4. 5 times 1 is 5, plus 4 is 9. 8 times 2 is 16, carry my 1. 2 times that is 2, plus 1 is 3. So we get 9, 0. 9 plus 6 is 15, 5, 1. We get 450. I'm going to do that in reverse just to make sure. And we have to accommodate for the decimal point there. So we're going to go over here once again. So that's equal to 45. And let me just do it in reverse to make sure we have that. 25 times 1.8. So it's worth this double check. 5 times 4 is 40. 0, count on my 4, 8 times 2 is 16, plus 40, but plus 4 is 20. And 5 times 1 is 5. 2 times 1 is 2. So we get 0, 5, 4. Again, we move over 1 decimal place here. We move over 1 there, we get 45 degrees again. Okay? So that's one way to do it. There's another way to do it, which is to have observed. Let me change the color of the pen for 1 second. Observe that 1.8 is equal to 1 and 8/10. All right? Okay, and that maps into 18/10. And if we divide the numerator and denominator by 2, we get 9/5. Okay, that's kind of handy because then we can get 9/5 instead of 1.8 times the 25. Oops, that should be a 5 plus the 32. Right, I'm not finished here. Up here, I have to add the 32 back in. So my answer would have been 77, right? So anyway, this 5 cancels, and there we get 5 there. And we get 9 times 5 is 45, plus the 32 again. Okay, and that gives us 77. All right, we're looking for degrees Fahrenheit, and that's what we're going to get here. All right, so this problem was about mapping algebra and getting the right numbers back and forth. All right, so that was cool. And involved a little multiplication, a little savvy. I'm not really sure the fuchsia way was the superior solution, but at least lets us double check stuff. Okay, here we have an illustration, so we're going to look at that first. Number of drawers, total volume. This is something about jewelry boxes. So this must be the number of drawers in a jewelry box and the volume of that same respective box. So it seems that if there's 2 drawers, the volume is 5. If there's 3 drawers, the volume is 7.5. I notice that this when that doubles, that doubles. Okay, so that might be helpful here. Maybe this is about rate, constant of proportionality, perhaps. In fact, I'm also seeing the formula for here. This is times 2.5. That's leaping out at me. In other words, 2 times 2.5, right, gives 5. 4 times 2.5, right, 4 times 2 is 8, plus a half is 2, gives 10. And then 3 plus half of 3, right, which is 1.5, gives that as well, right? We're going to double it. 3 plus 3 is 6, and we get 7.5. So that's definitely the rule there. Maybe that has nothing to do with what they're going to ask us. So we beat the illustration to death at this point, so let's go actually look at the words. Michelle makes jewelry boxes containing drawers of equal size. Okay? They're equal size. The drawers are of equal size. So that may come into play here. Let's see. The number of drawers in 3 different jewelry boxes and corresponding volumes. That means the 5 matches the 2, the 7.5 matches the 3, and the 10 matches the 4. That's what they're talking about, corresponding. And the drawers are shown below in the table below. Okay, cool. Write an equation for the relationship between the number of drawers, D, and the total volume of the drawers in the jewelry box. Okay, so it seems to me I figured that out. It's 2.5 times the number of drawers is the volume. All right, and sometimes you need to experiment a little with this to get it. Okay, sometimes it doesn't always leap out directly. So what you want to do is sometimes tinker about, and then you can basically get it. So that was the first part of this. And then there's the second part. It says, use your equation to determine the number of drawers in a jewelry box with a total volume of 17.5 cubic inches. So this is basically what we have then for that part of it. And we divide both sides by 2.5. This cancels out. And now we have to do 2.5 into 17.5. Okay. I don't like using decimal numbers on the outside. So we can move this decimal point 1. we can move that decimal point 1. So we get 25 into 175, and that becomes what, 7, right? 25 times 7, because 25 into 1 we can't do it. 25 into 17 we can't do it. 25 into, why did I write 5 there? That's 7. 7 times 5 is 35. 3, 14, 7, yeah, so we get 7. All right, so the number of drawers in that case, we would have had 17 and 17.5 here if we were to add on to the bottom of that, okay? So this is testing a whole bunch of stuff. It's testing our analytical skills to basically look at the illustration and make sense of it. And by the way, now that we have the formula, I said this here and this here were ratios because we had 2:5. If I double that, I get 4. If I double the 5, I get 10. And the reason that's true is because of this. All right? Because basically we had 5 is equal to 2.5 times 2, right? So that means 10 is equal to 2.5 times 4, right? So if we double that, this part stays the same. So if we double that, we have to double this, okay? So this is about ratios as well, even though it was basically testing us again on writing an equation. That's really the crux of the matter of this problem, is getting that equation written properly. All right, so spend your time on that kind of a thing. We're mapping the jewelry box and the English into the formula, okay? We could have solved this another way, which actually is the incorrect solution, but we could do it. If we notice the number of drawers over the volume, and we can, because these 3 are true, 2, 5, 3, 7, 4, 10, we can pick one arbitrarily, which would be the 2 over the 5, the drawers to the volume, right? And we can say that's our ratio. So if we're trying to find x over 17.5, we could have used that. We can do the cross product. Get 17.5 times 2 equals 5x, right? So we could have done it that same way there and got the same answer. But 17 times 5 times 2, we get 34 plus 1 is 35 equals 5x. Divide both sides by 5, and we get 7 equals x again. All right? So it was that 7 we were looking for. They gave us the 17.5. All right? So this is core algebra, if you will, and it's mapping things to get that equation going. That's really the concept here. And again, the answer was in drawers. So just to be sure, we're not looking for volume here. We were looking for the number of drawers. And again, it has to make sense. If you look at that table, 17.5 is the largest number comparing the 5, the 7.5, and the 10. So if you got an answer of like 1, you have to know that's wrong. Just use your logic to do an estimation. So 17.5 is teetering on 20. So if 4 was 10, then 17.5 is closer to 8, and it turned out to be exactly 7. All right. They gave an example where the number of drawers was equal. If they gave 17 as the volume, then we're not going to get an equal number of drawers. Okay. And that's why we come back up to here, where it talks about of equal size. That's part of what's going on there. We know all the drawers are the same size. If they were different sizes, we'd have to solve this a different way. And in some cases, this would not be solvable at all. Okay. All right, so we have a bunch of numbers leaping out here. Jan bought a crate of tiles for $95, so the cost was $95.94. So we're up to here. The crate had 6 boxes of floor tiles. Okay, this is cost, not crate. So there's 6 boxes of floor tiles. That is probably significant. Each box contained 20 floor tiles. Okay? Write and solve an equation to determine the cost of the box B. So I use the word cost. They're saying that's B. Okay? Well, that's the cost per box. So this is I'll call this T for total cost, or TC, total cost. Okay, then write and solve an equation to determine the cost per tile to the nearest cent. So when they use that, there's probably rounding somehow involved here. Okay, they're not asking us to estimate anything. They're asking us to get some value, and at the very end, just do a rounding. Since this is in dollars and cents, right? That's what this was. This was in dollars. There's probably a fraction of a penny at some point that comes into play on this example at some point. And by the way, this question would be normally worth more versus some of the other questions we just did. Okay? And by the way, we have one more question after this, I believe, so we're just about done, or unless I go on my normal banter around speak. So, so what we basically need to do is we have the cost, right? Well, we have B is going to be equal to that total cost, TC, right, divided by 6 as one thing, right? And then that whole thing divided by the number of tiles. Okay? So what we're going to have is 95.94 divided by 6. Yeah, little t is the cost of that. Okay. So 6 goes to the 95 once. We get 3 left over. 6 times 6 is 36, so it has to be 5. The decimal point carries up. 5 times 6 is 30, so we get 5 more. This is 59, so we can't do done. We can do 9. 9 times 6 is 54, and we get 5 more. And 9 times 6 is that. So we get 1599. And we're going to divide 20 into that. Okay. So what we did was there's 6 boxes of floor tiles. So this is the cost per box. All right. So that's B. So this is what we need to do. This is the total cost over the 6. All right. That's what I said. Write, solve an equation to determine the total cost per box. Then write, so we have number 1 here, so we solve that. Number 2, then write and solve a second equation to determine the total cost of the tiles. So the cost of the tiles is equal to B over 20. So that's what we're doing here now with that. 20 goes into 1, can't do. 20 goes into 5, can't do. So we carry up the point. We can write the 0 here if we want. 20 goes into 159. So for that, we're going to get, well, if it's 8, it's 160, so we have to do 7. We get 140. Okay, that's 1, that's 9, that's 9. Okay. And we can do 9 there as well. Okay, that gives us 180, and we get 190 again because there's another 0 we have to drop down. So 9 times 2 is that. So we basically get 0.799. This is where this nearest cents concept comes in, and that's 80 cents, right? So we write 0.80 or 80 cents in words. Okay, if we look at what they want for the answer, what does it say? Per box. So this would have been $15.99. And since they want these in dollars, we would write 0.80. 0.8 of a dollar, right? So that's basically the way we normally write that, okay? So that's what they're looking for there. So this was, again, about writing equations, and it was pretty much just a simple division. Theoretically, we could have got the 80 cents by doing 95.94 divided by 20 divided by 6. However, they wanted us to do step 1 first. All right, we still got the 80 cents doing that this way, but that's not what they're asking us to do, so we shouldn't be doing that, all right? And this is not 95.94 times 6 times 20. We could have also done the 95.94 divided by 120 to still get the 80 cents, but that doesn't help us getting the B. Okay, that only gets us the T. So no matter how you slice this, you had to write those two equations. This is number 1, that's number 2, and that would have gotten you that. All right. So this is testing again, algebra, basic algebra, and basic division, which also involves multiplication at the same time. These ones have really strictly focused well. And that was a 3-point question. This is also a 3-point question. So here we have a couple of tables. So this is either going to get messy real fast or not. So let's take this a piece at a time. There's a days here, Chinooks, steelheads. Hopefully that tells us what that is. Salmon. So this might be a type of salmon. That's another type of salmon. And it says counted. So for some reason they're counting different kinds of salmon on different days. Can we see a pattern here? Nope, because even though steelhead goes 10 to 30, it goes back to 20 and then 15. Same for Chinook, 4, 12, 8. Is there a pattern going across this way? Perhaps there is. It might be the 2.5 again. 4 times 2, 8 plus 2 is 10, 12, 24. Yeah, it's 2.5 again, going across. 8 plus 16 plus 4 is 20, right? 12 plus 3 is 15. So they're probably going to ask us this, and we can actually predict it already. It's 2.5. So we have 16 is 32 plus 8. It's probably 40. Okay? And since these are all in ratio, right? This is times 3. That's times 3. This is times 2. This is times 2. If we come down to the 16, this is times 4. This is times 4. So we have a way to double check. The answer is 40. We don't even know if that's what they're going to ask us. So let's go back here and look at the words. A biologist counted the number of 2 types of salmon, the 2 types being Chinook and steelhead, at a dam. Cool. He used the table below to record the number of salmon on different days. Awesome. On day 5, the biologist counted 16 Chinooks, so that's what they're telling us right there. If the ratio of Chinook to steelhead remained the same as the previous 4 days, how many steelheads should the biologist expect to count on day 5? All right, so I did this in 2 ways. I used the constant of proportionality. In other words, I said steelhead is equal to 2.5 of the Chinook. Okay, that was just producing a formula straight up. Okay, they're asking you to use a ratio. So that was the second way I did it. If 4 is to 10, if I take this 4 and that 10, then 16 is to what? That's basically what we're looking for. So we can observe this was 2.5 and that was 2.5. Or we can do the cross product. 4x equals 10 times 16. So 4x equals 160. Divide both sides by 4. That kicks out. This becomes 40. Right? So that's what they're asking us to do. So that was the first part of things. Now there seems to be more. So plot the salmon count from the table below. It says label each point. If you don't do this, you're not getting the credit. All right? So this is a pain in the neck. So This is, the Chinook is our X. Well, in fact, it tells us. Chinook is here, so that's our X. And Steelhead is our Y. So remember, we have these in X, comma, Y form. So that means this is our X, and this is our Y. So let's go. The X goes back and forth. Move the ladder back and forth, and the Y goes up and down the ladder. Okay, so Chinook was 4, 10 is here. Okay, it says label them, so this is day 1. Okay, the second one is 12, 30. So that's number 2. Okay, 3 is 8, 20. Okay, so they're not in order, if you notice that. Okay, 4 is 6, 15. They're not in order, but they look like they're making a line, right? And 5 is 16, 40, which is here, right? So there is a line there. It doesn't ask us to draw that line. It just says label the points. So there we go for that, okay? And that is the last question. All right, guys, so this is part 1 of the grade 6 show your work questions. We're going to do a part 2. There's probably 5 or 6 or 7 or 8 parts we're going to end up doing before we go into the next part. Remember, by the way, if you find these too challenging, you can go back to the grade 5 questions, the show your work ones and the multiple choice ones. And if you find these too simple, well, you have to wait, because as I add more of these, you might find some of them harder. And if you find all the grade 6 too simple, then you're going to have to wait till I start doing grade 7. That said, I've already done grade 7 and grade 8 of the multiple choice. So you might want to go and look at that. In the meantime, have a great day. Please like and subscribe. Don't forget that. There's more to come. All right, guys?